Alrighty guys, so today's lecture is about the different types of elements and molecules. So before we start with that, let's kind of review the differences between the two. So an element, we talked about this last time, but basically an element is just one atom. It's a single particle. So if I drew a picture of an atom, it would be something like this. You would just have one dot. It's just one Lego block. Okay? And the difference is that a molecule is that it's made up of two or more, so 2 plus atoms. Okay, so an example of a molecule, it might look something like this. You might have like 3 atoms stuck together. You could have 2 atoms stuck together, or you can have like a bajillion atoms stuck together. Okay, and the more complex chemicals that exist, there are a lot more atoms linked together. Okay, so the following, we have 4 different chemicals here, and we're just going to figure out, are they elements or are they molecules? So we said elements are things that are just one atom. Okay, basically if you go on the periodic table, if there is, you just basically look for the symbol. So here we have P. This is phosphorus. Okay, and phosphorus, it's just one capital letter in the formula. Since it's one capital letter, it's just one element. So this would be an element. Okay, but if we look at this one right here, CH4, this is called methane, and methane is made out of different elements. We can tell because there are multiple capital letters inside of the formula. There's a capital C and there's a capital H. Okay, that tells you that this one is carbon. So there's one carbon, and then this one we know is hydrogen. Okay, so this is different elements stuck together, so this would be a molecule. And if we drew a picture of these, if I drew phosphorus, it might look something like this. It would just be one dot. But if I drew a picture of CH4, you would have to draw one carbon, and then you would have to draw 4 hydrogens connected to it. So you can kind of see the difference between the two of them already if we draw a picture. One of them is just one dot. The other is 5 total dots, 1 carbon and 4 hydrogen. Same thing here, we have NH3, this is ammonia. And this one right here is made out of nitrogen and 3 hydrogens. Okay, and we know that because there are multiple capital letters. So this one, the capital N, is nitrogen. And this one right here, the capital H, is hydrogen. And so this one is going to be a molecule. And if we drew a picture of this, we would draw nitrogen in the middle, and then we would draw 3 hydrogens connected to it. So you can tell that there are multiple things making up these molecules. And then right here we have 2 different letters, but we have Ca. Now the C is capital, but the A is not capital. That means this is one element. So if you go look at your periodic table, you'll see that this is the element calcium. And so this is one atom, so if we drew a picture of it, it would look something like that. It would just be one dot. Alright, so that's how we basically draw the pictures for elements and molecules. Now let's do a little bit more review before we move on. So we have some different chemical formulas, and basically we're just going to figure out how many elements or how many of each element are in the following atoms. So here we have KMnO4. Now if you look at K, there's no number behind it, right? Okay, there's no number behind it, so that means we only have one of it. So we have one K. Okay, we have Mn, but the N is lowercase, so that means it's not. This is all going to be one element. We have Mn. This would be another element. Okay, and we have one of those since there is no number behind it. And then we have the capital letter O, and there's a number 4 behind it, so we would have 4 O's. So remember that the number behind only applies to the element that's right in front of it. Okay, it's not 4 Mn's, 4 K's. It's only 4 O's because there's a 4 only behind the O. Alright, let's review parentheses again. Now parentheses are a little bit trickier because basically what you need to do is you need to multiply the number on the outside of the parentheses with everything on the inside. Okay, so let's see what that's going to look like. So let's look inside the parentheses. So what's inside the parentheses? It looks like inside the parentheses we have a carbon, right? We have C, and there's no number behind it, so that means it's going to be 1. we also have two H's, right? We know that there's two H's because there's number 2 behind the H. So there's two H's. Okay, but we see this whole thing is inside a parentheses, and there's a 3 on the outside. What that means is you're going to have to multiply everything on the inside of the parentheses by 3. So basically there are 3 C's, and there are 2 times 3, 6 H's inside the parentheses. So inside the parentheses, we have 3 C's and 6 H's. Outside the parentheses, it looks like we have 1 O because there's no number behind it. So we would have 1 O. And then it looks like there's 2 more H's outside the parentheses. So that means we would just have to add 2 H's. And this comes from right here. So that means for our final answer, we have 3 carbons, we have 6 plus 2, we have 8 hydrogens, and we have 1 oxygen. And that is what makes up those molecules. So as the formulas get bigger, the more elements go into it, but the rules for figuring out what elements are in the molecules is very easy. You just look for the number behind the element, and for the parentheses, just multiply everything on the inside by the number on the outside. Alright, so that's going to be it for review, and what we're going to do now is we're going to talk about the different types of elements and then different types of molecules. So there are 3 different types of elements. Now the first type of element are called metals. Okay, and this is something that you guys are probably already familiar with. Okay, so the key things about metals is that, as you guys probably know, they're solid at room temperature, right? If you probably have some metal at home or something that is made out of something that's made of metal. Okay, and so we have a picture of a metal ore. This is what they look like when we dig them out of the ground. And then what we can do is we can process them to look like all different types of metals that we're familiar with. Some other characteristics of metals is that they are shiny. Oh, one quick thing I forgot to mention. They're all solid at room temperature except for one of them, which is mercury, Hg. And this is the thing that's inside your thermometers. And as you guys know, that thing is liquid because it's able to expand and move up your thermometer and down depending on the temperature. Okay, like I said, metals are also shiny. You guys probably noticed that when you guys look at things made of metal. They're good conductors of electricity and also heat, and this is why we use metals to make wires so that they can carry electricity. We also use metals for like frying pans and things like that because they're also able to have heat flow through them very well. They're also ductile, which means they can be drawn into wires. So if you guys play guitar, you guys know that the strings are made out of metal, and the reason why they're made out of metal is because metals are able to be drawn into these wires. Okay, they're ductile. They don't just break when we try to make them very thin. Okay, they're also malleable, which means that we can make them into these different types of shapes, right? We can make all different types of shapes with metals, and they're able to keep that shape. Okay, now if we look a little bit more chemically, metals like to lose electrons. Okay, so if we have metals, they like to get rid of their electrons, and so their most common ions are cations, which means they become positive. An example would be Na. Na has 1 valence electron, and what it likes to do, as you guys know, is it likes to lose that electron and become Na plus with 8 valence electrons. Okay, so how do we find metals on the periodic table? Now, if you guys go on Canvas, you guys will see a new file that's called metals, nonmetals, and metalloids, and you'll be able to download an image that looks something like this. Okay, what I have on the right side of the screen. Okay, so if you guys look on the screen, everything that's yellow, every element on the periodic table that is yellow is going to be a metal. So if you notice, most of the elements are metal. So everything in yellow. So everything on the left side, the middle, and the very bottom, these are all metals. Everything yellow in that picture is a metal. Okay, the only exception on the left side is hydrogen. That's a nonmetal, which we'll talk about right now. So what are nonmetals? Nonmetals are basically like the opposites of metals, and they're here on the right side. So everything in green right here is going to be a nonmetal. Nonmetals are known to be brittle, which means that when you like hit them, they tend to shatter and break. So this is a picture of sulfur, and you guys notice it's like crumbling, right? Metals don't really crumble. They can break, but they don't crumble into little itty bitty pieces. Okay? They're also poor conductors of heat and electricity. We said earlier that metals are able to let electricity go through them. They're also good at letting heat go through them, but nonmetals are the opposite. They don't let heat and electricity go through very well. We said earlier that metals are solids at room temperature, but nonmetals, they could either be solid, liquid, or gas. And so if you look at a picture of this, we have a picture of bromine. Bromine is right here on the periodic table, number 35. It's a nonmetal, and at room temperature, bromine is a gas. We also have carbon. Carbon is also a nonmetal. Carbon is a solid. Okay, here we have sulfur, which is also a solid. And then we have phosphorus, which is also a solid. Okay, but things like nitrogen, oxygen, fluorine, you know these ones as gases at room temperature. And so nonmetals can be solid, liquid, or gas at room temperature. Okay, they're not uniform like metals are. Now the thing about nonmetals is they like to gain electrons. So it's the opposite of metals. They like to gain electrons, and because they gain electrons, their MCIs, their most common ions, tend to be anions. So an example of this would be fluorine. Fluorine has 7 valence electrons, and you guys know this already, but it likes to gain an electron and become F- and have 8 valence electrons. Okay, and nonmetals are basically everything on the right side, the green stuff on the periodic table. All right, the last type of elements on the periodic table are called metalloids, and metalloids are they're kind of a combination. They have a combination of properties of metals and nonmetals. They're kind of in the middle. Okay, so metalloids, again, they have properties that are a cross between metals and nonmetals. Here are some pictures of different metalloids. We have boron, number 5, in the purple on the periodic table. We also have silicon, germanium. Now they look like metals, right? So metalloids they tend to look like metals. Okay, but they don't really do the same things as metals. So we said earlier that metals are really good at conducting electricity. That's why we use them to make wires so that electricity can flow through them well. But non-metalloids are only partially conductive, which means they kind of let electricity through, but they kind of don't. So it's like kind of an in-between between metals and non-metals, because non-metals don't let electricity through them very well, but metalloids are kind of okay at it. And so we use them for semiconductors and in computer chips where we don't want electricity to flow too well, but we still need some electricity to go through them. Okay, so those are metalloids. Alright, so on your assignment today, you're going to have to basically figure out, are some elements metals, nonmetals, or metalloids? Very easy. So I have some examples. So we have an example of tungsten. Tungsten is right here, 74. It's W. And tungsten, it looks like it's yellow, so it's going to be a metal. Uranium is U, so if you take a look at that, number 92 on the very bottom, it's yellow, so it's also a metal. If you feel confident doing this now, and I think most of you guys should be, take a second to pause the video and try out the next two on your own. Okay, so let's check your answers. So we have krypton. Krypton is number 36 Kr, and it looks like it's green, so it's going to be a non-metal. And then lastly, we have germanium, which the symbol is Ge. Ge is right here, number 32, and it's purple, so it's going to be a metalloid. Okay, so that's basically how you figure out if something is a metal, metalloid, or non-metal. Alright, so those are the 3 types of elements. Now what we're going to do is we're going to talk about the 3 types of compounds or molecules. Alright, so there are 3 types of molecules. We'll talk about the first one. Is called ionic compounds. Okay, now ionic compounds are made out of metals and non-metals. So that means it's made out of something yellow on the periodic table, and it's made out of something green on the periodic table. It has to be a combination of those two. Okay, And so basically what happens in an ionic compound is the cation is the positive ion, and this is usually going to be the metal. The metal gives the electrons to the anion, the one with a negative charge is going to be a nonmetal. So in an ionic compound, the metal gives electrons to the nonmetal. So we'll talk about that here. So we have Na and we have Cl. We'll go more into detail tomorrow, but basically Na is the yellow one. Sodium, it's a metal, and we have Cl, which is the green one. So this is the non-metal. So here we have the metal, and then here we have the non-metal. So what's going to happen is Na is going to give electrons to the Cl. Okay, and that's basically how they combine together. It's going to give electrons to Cl. That makes Na positive and Cl negative, and the positive and negative are going to bring them together. Now we'll go more into detail about that next time, but just know that the metal is going to give electrons to the nonmetal. So here we have Kf. K is right here, potassium, and F is fluorine. K is going to give electrons to fluorine. We have some instances where we have more than one metal. So here we have two NAs and we have an O. So this molecule might look something like this. Na, there's two of them, and then there's an O, and both of them are going to give electrons to O. Okay, and then here we have another example of an ionic compound. We have aluminum, which is a metal. And then we have sulfur right here, which is also a nonmetal. And so there's two Als and there's three sulfurs, and basically the Als are going to give electrons to the sulfurs. Okay, so the electrons are going to go from the Al to the sulfurs. And that's basically what an ionic compound is. Just know, in order to figure out if something is an ionic compound, you just need to see, hey, is it made with something in the yellow part, a metal, and a green, a nonmetal. It has to be metal and nonmetal. Alright, the second type of molecules or compounds are called covalent compounds. And covalent compounds are made out of nonmetals plus nonmetals. So basically it's going to be when the things in the green right here, they combine with each other. Okay, and here the atoms share electrons. We'll go more into detail about that later, but just know that for covalent compounds, they have to be made with multiple nonmetals. So here we have CO2. If you notice, C is a nonmetal and O is a nonmetal. So since both of these are nonmetals, these are going to be covalent compounds. Another example, water, H2O. H is a nonmetal, it's green. O is a nonmetal, it's green. Since they're both nonmetals, it's going to be covalent. And also here we have O. O is going to be a nonmetal, and since there's two of them, there's two O's, it's going to be, they're both nonmetals, so it's going to be covalent. Okay, so the key here again is just know that it's made out of nonmetals. Covalents are nonmetals. Alrighty, and the last type of molecule or compound are called alloys, and alloys are made out of metals and metals. And earlier we talked about how ionic compounds give electrons, covalent compounds share electrons. Here the electrons basically move freely. Okay, so here we have a picture. Basically the metals are kind of just, they're stuck in one place, but the electrons basically just move around. So if I'm this electron, I'm not stuck to one atom. I can just kind of move around all of the metals. Okay, that's basically what happens in alloys. In alloys, the electrons can move around freely. Some examples of alloys that you guys might know about, brass. Brass is a combination of copper, Cu, which is a metal, and also Zn, zinc, which is a metal. So these are two metals. Bronze is copper and tin, Sn, so it's a combination of these two. And then stainless steel, which probably a lot of things in your house is made out of. It's made out of Fe, iron, it's made out of chromium Cr, and it's made out of nickel, which is all three are metals, and that's basically what alloys are. It's basically when you have multiple metals mixed together. All right, so for your assignment today, you're going to also have to figure out are different compounds ionic, covalent, or metallic. Okay, so before we do the problems, let's kind of remember our notes. So for ionic compounds, we said that they are made out of a metal and a non-metal. Okay, for covalent, we said that they are made out of non-metals. And then lastly, we have alloys, which are made out of just metals. Okay, so our first example is O3. Actually, I'm going to make the formulas a little bit bigger just so they're a little bit easier to see. All right. So our first example is O3. So O3 is only made out of one element, right? There are 3 oxygens. Okay, and if we look at oxygen on the periodic table, oxygen is in the green part, which is a nonmetal. So these are nonmetals. So if this molecule is made out of only nonmetals, which one of these 3 are they? Okay, hopefully you said that this one is covalent. And the reason why is that it's only made out of nonmetals. All right, so if you guys feel pretty confident doing this, feel free to pause the video and try it out on your own, but if not, I'm going to go through it step by step. So the next problem here, we have UF4. It's made out of 2 different elements. It looks like there's U, so let's look at what U is. U is yellow, so that means uranium is a metal. If we look for F on the periodic table, F is right here. It's in green, and so F is a non-metal. So if we have a metal and a non-metal, what type of molecule is it? It's going to be ionic. Okay. Here we have a big old complicated looking molecule. We have CH3CH2OH. So if we look at what type of element they are, so if we look for C on the periodic table, it looks like C is a non-metal. So both of the carbons are basically just non-metal. If we look for H, H is also green, which means that H is also a non-metal. And then lastly, we have O, which is also in green, so O is also a non-metal, which means that all of the elements that make up this molecule are non-metal. So which one of the 3 would they be? Okay, hopefully you said that it's covalent. All right, and number 4, last example, we're going to look for K on the periodic table. K is right here, number 19, and it looks like it's yellow, so K is going to be a metal. We're going to look for Mn. Mn is 25, which is also yellow, so Mn is also a metal. And then lastly, we have O, which is green, which means that it's a non-metal. So here we have 2 metals and a non-metal. Okay, so which one of these 3 would that fit? Okay, hopefully you said that it's ionic. It's ionic because even though there are 2 different types of metals, it's still metals combined with non-metals. Alrighty guys, so that's how you determine the different types of elements on the periodic table and the different types of molecules that we can make. I'm on the Zoom call right now, so let me know if you guys have any questions. But that's going to be it for today. Good luck, and I'll see you guys next time.